Hey guys, welcome back to another video of the R Programming for Beginners series. Now in the last episode, we talked in detail about what data frames are and how we can work with them inside of the R programming language. And in today's episode, we're taking a step into another topic, that is operators in R. So let's get started with the video. Now before we start coding, we need to understand what operators actually are. Well, operators are symbols that allow us to perform actions. Actions like adding numbers, subtracting numbers, comparing values and seeing if values are greater than one another, and also checking logic. You can think of them like verbs of programming. That is, if you add operators with values, you'll get some results. Okay, now that we have a basic idea about what operators are, let's look into the types of operators in R. In R, operators mainly come in three groups: arithmetic operators, comparison operators, and logical operators. We'll learn about them one by one and then apply them to real data. Well, before we work with operators physically inside of our compiler, let's know that operators return results. Operators don't just sit there. They take values, they perform an action, and then they return an answer, often true or false values. Now this becomes important when we filter data and make decisions later. So example is a comparison operator is being used right here, that is 5 is greater than 3. This will return a true value. And an arithmetic operator, that is the plus, or let's say the addition operator, will return a value of 2 plus 2, which will be 4. And not only single number values, but R operators work with vectors as well. Since R is vector based, operators don't only work on single numbers, they apply to entire sets of vectors automatically. So adding one vector to another would give us the following result. And when using operators on vectors, they add, or let's say perform operations with the corresponding values. That is, 1 will be added to 4 and produce 5. 2 will be added to 5 because they are both in the second position of each vector, and it will give us a result of 7, and 3 will be added to 6 and give us a result of 9. Okay, now that we have discussed about the theory regarding operators in R, let's actually have a practical coding demonstration inside of our R compiler. Okay, so we are inside of our R compiler. So first let me increase the font size for you guys so that you can see this clearly. So first of all, we'll use a bunch of arithmetic operators. So let's say arithmetic operators. And then we will first of all do addition. So 5 plus 3. Then subtraction, 10 minus 4. And multiplication, which is symbolized by 6 times 2. And then division, 8 by 2, and then power, so 2 to the power of 3, and then a modulus operator, which is 10, and then 2 percentage signs, 3. Now I'm sure you're familiar with all of this, but you guys might have some confusion in this modulus operator right here. But before we explain what this does, let's actually see the output of using these operators. So as expected, all of these operators will do their assigned function, that is addition will perform addition, 10 minus 4 is 6, so subtraction, 6 times 2 is 12, 8 by 2 is 4, and 2 to the power of 3 is 8. But what is this 1? Why is 10 modulus 3 returning 1? Well, using a modulus operator, that is these 2 percentage signs, returns you the remainder of a division. So remainder of the division. Now let's say here is 11. We know that 3 times 3 is 9, and the next multiple of 3 is directly 12. So the quotient of 11 by 3 will return actually 3. But there is still a remainder of 2. So 11 modulus 3 will give us 2. So you can see that clearly. Now if I do 10 and then 2, what do you think will happen? Well, since 10 is perfectly divisible by 2, it will leave no remainder. Hence, 10 modulus 2 will return a value of 0. So, you can see that clearly. But when I do 11, once again, it will return 1, since 1 is the remainder of 11 divided by 2. So I hope the modulus operator and all of these arithmetic operators are clear to you guys. Now after the arithmetic operators, we'll be working with a bunch of comparison operators. So let's comment all of this, and then we'll be moving on to, okay, let's actually remove all of this, and then we will be moving on to comparison operators. So comparison operators. And as for comparison operators, we'll be looking at 4 to 5 comparison operators. First, we have if comparing two values are equal or not. So when I do 5 equals to a double equals to 5, it should compare the values. Now remember that 5 single equals to 5 is a assignment operator. Now I know that traditional values assign, so let's see, if we had a variable called x, we would traditionally assign the value of 5 to x with the arrow symbol, but you can also do it with an equals to sign. So it is important that when you compare values, you use two equals to signs, because this is actually the comparison operator for equals to. So in this case, we are comparing if 5 is equal to 5. Now this should obviously return us 2 since 5 is equal to 5, but let's say if I do 5 plus 2 is equals to 4 plus 3, this should also return us a true value, since 5 plus 2 is also 7 and 4 plus 3 is also 7. But what if we did 4 plus 2? Now this is 6 and this is 7, 6, 7. But what if we do this? So since this is 7, or let's say this is 6 and this is 7, it will give us a false value. Now I hope the comparison operator is clear to you guys. And after that, what we will do is we will compare if a value is not equal to the other value. So the symbol for not equals to is first of all not, which is an exclamation mark, and then equals to. So in this case, we are looking if 3 is not equal to 4. Now this statement is actually true. 3 is not equal to 4. So this will give us a true value. So true. But if we put there 3, this statement says that 3 is not equal to 3, which is false. So this will give us a false value. Now after that, we have the greater than and lesser than value. So these are pretty simple. It will just compare if 7 is greater than 10, which is false, so it will return a false value. And if we flip the sign and turn it to lesser than, it will give us a true value. And once again, we have lesser than or equals to. Now this is a bit different. Now this also checks if 7 is equal to 10, which is still true, since 7 is less than true, although it is not equal to 10, but it is less than 10. But if we did 7 is less than or equal to 7, this will still give us true, since 7 is equal to 7. So I hope you understand that clearly. Now comparison operators check relationships and return true and false values, as you have observed. So this will be the foundation of filtering data and if-else logic later. Now that we know about comparison operators, let's move on to logical operators as well. So logical operators. So when talking about logical operators in R, there are two types of operators. One is the, okay, let's say one is the element wise logical operators, and then next is just the default logical operators. So what are the element wise logical operators? Well, the element wise logical operators are two symbols. One is the ampersand symbol, so the ampersand symbol, and then the pipe symbol. So these are the logical and, or let's say the element wise logical and element wise logical or. And then there are the logical operators, which are double ampersand symbols and then double pipe symbols. Well, these are logical operators in general. Now beginners might wonder what is the difference between these two. Now these both operators compare logical values, but there is a twist. Now as the name suggests, when using element-wise logical operators, R compares values element-wise, which is position by position. Now let me demonstrate what this means. So let me first of all cut all of this, and let's say we have two vectors. First of all, the vector x, which contains 3 values. So true first of all, false, and then true once again. And let's say we have another vector, but this time it is y, and then y has of the value of true, true, and then false. Okay, meant to type false. And now let's use the logical operator that is ampersand y. Now, when using ampersand operator y, this compares the values. Now for this to return a true, okay, let's just say that logical operators return a true or a false value. Now for this to return a true value, first of all, when using AND operators, whether it is the element-wise operator or just the logical operators as double ampersand symbol, first of all, this will return true only when both of the values are true. So only true and true will return a true value. So in our case, when we use x and y and make it run, you will see that it returns a true, false, and false value. Now I will say why this is so. Now like I said before, it compares values position by position. Now first of all, the first position, first value is true, and inside y2, the first position value is true. So true and true give us a true value. But in our second position, x has false, whereas y has true. So false and true value give us a false value. Now in order to give us a true value, both of these should have been true, like our first example. And so with this, even though x has a true value, y has a false value inside the third position. So our third position is a false value. See how it returned us a vector when comparing values between x and y. That is how the element-wise logical operators work. Now this is the AND operator. Now let's see what x and then OR y gives us. Now when doing this, you can see that all of these are true. Since for a logical OR operator to return a true value, only one of the values that are in the comparison have to be true. So it will only return a false value when both of these are false. So when we do false false and run it, we can see that it provides us a false value. Since both of these are false, OR operator returns false. Now let's have a realistic numeric example instead of just true and false values. Let's say we have still a vector called numbers, and let's say the numbers vector has the values of, first of all, -2, 3, 8, and then 15. Now let's say we have to compare numbers. So when I do numbers greater than 0, what this will do is tell us if all of these values are greater than 0 or not. So when we run this, it will return us false, true, true, true. Since only -2 is not greater than 0, it returns us false and everything is returned true. In a similar way, when we do less than 0, or let's say less than 10, all of the initial values will return true since all of these values are less than 10, but 15 is not less than 10, so it will return false. Now, what if we want to combine both of these conditions? That is where the logical operator comes in. So, inside of our code, when we do numbers is more than 0 and numbers is less than 10, this AND operator, or let's say the ampersand operator, will check both of these conditions and will only return a true value if both of these conditions return true. So for each of these number, our AND operator will only return true when the number is both greater than 0 and less than 10. So let's run. And we can see that only 3 and 8 return a true value since these are both greater than 0, 3 is greater than 0, and 3 is less than 10 as well. So this AND operator, or let's say the ampersand operator, returns a true value. Now, what would happen if I use a logical OR operator? Now for this question, I want you guys to drop your answers in the comments below. If you're watching this video and interacting, I want you guys to answer this. This is quite simple and you might already know the answer. So I hope you guys answer this in the comments below. Okay, now that we have talked about the element-wise logical operators, let's talk about logical operators in general. Once again, I have the two previous vectors, that is x and y, which both hold true and false values. Now instead of using x ampersand and then y, let's use two values because this was the element-wise operator, and let's use the actual logical operator. And let's see what happens. First of all, this should be a small x, and then it would give us an error. Error in x and y, length equals 3 in coercion to logical 1. So this might give you a hint, but the logical operator, that is two ampersand values, only work for single values. So instead of a vector, we only get one true or false. So in our case, we should first of all use 1 in order to access this true value and then compare these two values. So true and true should return true, and let's say both, let's compare, okay, this should be, let's say this is true. So let's compare x2 and then y2 as well. So first of all, this false value and true value, and let's see, it will return false. And same with the OR value. When we use two pipe symbols, it will perform operations with a single value instead of the whole vector. So it will give us true since at least one value is true. Let's turn this to false and let's observe. It should return false. So by this, it should be clear that the logical operators, the general logical operators, that is two symbols, only work with single values. And that is why it is used only for decision making and not data processing. So I know I have not discussed about this inside of our series yet, but this is used inside of our if-else conditions, which are control statements. So I'll give a little demonstration. So let's say we have two numbers. So one is A and 2 is B. So 2. Now let's compare these values. If A is greater than 0, logical AND, so two ANDs, since we are working with single values, and B is greater than 0, let's say we will print that both the numbers are positive. Now let's run this. So both the numbers are positive is printed because this is true. A is greater than 0 and B is greater than 0. So I just meant to demonstrate that these kind of values are used inside of conditional statements like if-else statement. If a condition is true, execute this line of code. In those case scenarios, these logical operators are used. Whereas when processing data like vectors and comparing values inside vectors, we use the element-wise operators, which are just a single ampersand value and the single pipe value. So I hope that is clear for you guys. This compares a single value, whereas these can be used to compare multiple values and return all of them inside of a vector at once. So after this, let's head towards a quick summary. Okay, and as a recap of today's topics, we learned about arithmetic operators, comparison operators, logical operators, and that these operators work on vectors as well. So that was it for this episode. In the next episode, we're going to be dealing with conditional statements, as we discussed earlier, a teaser of the conditional statement, which was the if statement. That is, if a condition is true, you can execute a line or a bunch of lines of code. We'll be talking more about that. So don't forget to tune in. And if you liked the video or found the video helpful, please drop a like and subscribe to our channel for more such videos. And until the next video, bye bye and happy coding.